Hi, good morning, friends. So, yesterday we have completed the fourth unit, okay, where we discussed about industrial design. Okay, so today we'll discuss about the fifth unit that is called as design for manufacturing. Okay, so that is we are studying the now fifth unit. The first chapter in the first unit is design for manufacturing, and this next chapter is the rapid prototyping models. Okay, so today we'll discuss something about the design for manufacturing. Before I start with this presentation, I would like to give an example of General Motors. Okay, the General Motors division, they were manufacturing 3,500 engines of 3.5 3.8 liters V6 engine for every day. Okay, they are facing such a high production volumes. The company had a strong interest in reducing the cost of the engine. At the same time, they wanted to enhance the quality of the product. That is nothing but that General Motors, they wanted to have manufacture a high volume production, and they wanted to reduce the cost of the product, and they wanted to increase the quality of the product. These are the two bigger challenges they had. And one of the costly sub-assembly in the engine was intake manifold. Okay, the air intake manifold. So this was a very costly sub-assembly in the General Motors. So General Motors, in this connection, they created a team. Well, they created a team, and team is being asked to reduce the cost of this air intake manifold sub-assembly cost, reduce the cost of this sub-assembly, and at the same time they are being asked to increase the quality rather than compromising the quality of the product. So this was the challenge which was being posed to the engineers, the PDD engineers, okay, in the General Motors. And in this connection, the General Motor, they have designed, or they have come up with some solution about the air intake manifold, the sub-assembly. So earlier it was being made by the cast iron, aluminum castings, but now they have started using the composite materials for the air intake manifold. So this was the challenge which was being brought by the PDD engineers, and they took the challenge as a design for manufacturing and reduce the cost of the sub-assembly of the air intake manifold of the engine of the General Motors. Okay, with this example, I start with this chapter, and in the book they have given the examples of this air intake manifold. You can refer the figure 11.2, that is exhibit 2.2. So that is the original manifold which was made of cast iron, cast aluminum, and the redesigned manifold is made up of thermoplastic composite. Okay, this reduced the cost of the sub-assembly of the air intake manifold. So this was the challenge for the design for manufacturing engineers. Okay, now I can define what do you mean by the design for manufacturing. So as you know that the customer needs and the product specifications are useful for guiding the concept phase. Okay, so in the beginning we need to collect the customer requirements or the customer needs, and then customer specification have to be defined, and the concept building, we need to take these consideration into the factor. Then Later, the development activities teams often difficulty in linking the needs and specification to the specific design issue, okay, they face, okay, because while linking the actual customer needs and requirements, okay, to the specific design, they started facing problem, okay. So that we call it as design for X methodologies. Design for X methodology, that is called as DFX, okay. So where X corresponds to the 1 dozens of the quality criteria, okay, 1 dozen quality criteria. For example, reliability, robustness, serviceability, environmental effect, merchantability. Okay, these are all the the X signifies these quality characteristics. Okay, so that's why DFX, okay, DF design for any one of the or many of these quality characteristics is called as design for manufacturing. Okay, the most common of these methodologies is design for manufacturing, that is DFM, okay, which is the universal importance because of directly attached to the manufacturing cost. Okay, so there is nothing but all these quality parameters will be directly impacting the manufacturing. That's why we call it as design for manufacturing. So there are certain principles which applies the methodologies for achieving DFX. Okay, that is design for manufacturing. The detailed design decisions can have a substantial impact on the quality and the cost. Okay. Then the development team face multiple and often conflicting goals. Once the conflicting objectives or conflicting goals are being faced by the design engineer, how to go for trade-off with respect to the manufacturing and the quality. Then it is an important to have a metric which to compare the alternative design. Okay, so we need to have a metric, and by using those metric we can compare the alternative designs. Okay, so that is to be the one of the principle while applying the design for manufacturing concept. And dramatic improvement often require substantial creative efforts early in the process. Okay, when we want to have a breakthrough or dramatic improvement about the quality, okay, about the product, okay, so we need to have a lot of creative efforts how to be put in the product development. Okay, and well defined method assist for the decision making process. Okay, if the method is standardized, well defined, so that we can make better decisions for design for manufacturing with respect to the any quality characteristics X of DFX. Okay, so the manufacturing cost is the key determinant of the economic success of the product. Okay, so the manufacturing cost plays a very vital critical role in the manufacturing industry with respect to economy of the product to be manufactured. So the simple example of economic success depends upon the profit margin. Okay, so the profit margin earned on the sale of the product and how many of the product of the firm can sell. Okay, the profit margin is the difference between manufacturing selling price and the cost of making the product, that is called as the profit margin. The number of the units sold and the sales price are the two large degree determined by the overall quality of the product. The economically successful design is therefore about ensuring high product quality while minimizing the cost. Okay, the DFM, the design for manufacturing, is one method for achieving this goal. Achieving this goal, the effective DFM practice leads to low manufacturing cost without sacrificing the product quality. This is most important. Even Tata industry also, they will not going to sacrifice any product quality, but they keep innovating, they keep in search of the new technology, new method, of the new material, or the new approach, okay, for increasing the quality of the product and also reducing the cost of the price of the final product to be manufactured. So that's why this is what the main goal of the design for manufacturing. Okay, then DFM requires a cross-functional team. DFM is requires a cross-functional team. So that means the only one department cannot do anything, they cannot reduce the cost of the product. So in this context, the design for manufacturing is one of the most in, integrative practices involved in the product development. Okay, in product development, so this is the approach, the integrative practice. Okay, the design for manufacturing utilizes information for several types. Okay, the first one, the sketches, drawings, product specifications, and design alternatives. Okay, the second, the detailed understanding of the production and assembly processes. Okay, and the third, estimates the manufacturing costs, production volumes, and ramp up timings. Okay, these all the three essential informations are to be needed by the product design engineers. Okay, then DFM therefore requires a combination of most of the members of the development team as well as outside experts. So the design for manufacturing effort commonly draw the expertise from the manufacturing engineers, cost accountants, production people, manufacturing people, design people, and sales people, marketing people. So everybody they involve, okay, as a cross-functional team to arrive the product quality and how to reduce the cost of the product. So they go on brainstorming sessions in the meeting, and they try to propose the alternative methods, alternative designs, such that the quality of the product is increased and the cost of the manufacturing sub-assemblies or the assemblies try to reduce the cost of those things. Then the design for manufacturing is throughout the development process. Okay, the design for manufacturing is performed, that is nothing but every juncture or every phase of the product development we need to think of design for manufacturing. That is nothing but how to reduce the cost of manufacturing and how to increase the quality of the product. Okay, every stage of the product development. So that is called as the DFM is performed throughout the product development process. Okay, so then, so now we'll discuss the process, okay, the DFM manufacturing process. What are the phases or what are the steps are involved in design for manufacturing process. Okay, the first process is called as estimate the manufacturing cost. The second one is they reduce the cost of component, and third one is they reduce the cost of assembly. The fourth step is reduce the cost of supporting production, and fifth step is consider the impact of design for manufacturing decisions on the other factors. Okay, these are the 5 steps or the 5 phases of design for manufacturing process. Is it clear? So well, okay, you can refer the table or the flow chart which is depicted in the exhibit 11.3. Okay, so the design for manufacturing method, so how it is being followed in the industry. For example, you refer that figure, that is 11.3 exhibit of the Woolrich PDD book. Okay, the proposed in the first stage, okay, the proposed design arrives to the product development team and estimate the manufacturing cost. Okay, so we need to estimate the cost of manufacturing, and then we need to think of how we can reduce the cost of components, and next we could think of how to reduce the cost of assembly, and then how to we need to think of how to reduce the cost of sub-assemblies. Okay, the cost of the components, cost of the sub-assemblies, cost of the assemblies, and reduce the cost of supporting production. So there are some of the activities or the functions performed as supporting activities for the productions. How we can reduce those costs also have to be brainstorm. How to be brainstorm in a cross-functional teams, and then consider the impact of design for manufacturing decisions on the other factors. Then recompute the cost of manufacturing. Okay, then we need to decide that whether this design is good enough or not. Are we meeting the expected cost of the production, so that we can compete, so that we can sell our product in the market in competition with the other manufacturers, other manufacturing industries in the market. Okay, so after performing all this, we must decide whether the reduction of all the cost of the products, components, sub-assembly, assembly, is it enough? Okay, if it is enough, we must stop and we must accept the design for manufacturing. Otherwise, again you go back, again brainstorm, again think, and reduce the cost of the component, cost of the sub-assembly, cost of the assembly, and cost of the supporting for the production activities. Then again verify whether this is sufficient again. If yes, the design is accepted for production. This is how the industries adopt the design for manufacturing process. So this is one of the beautiful flow diagram for the design for manufacturing. Understand, students? Okay. So then, well, we'll discuss the first step of the design for manufacturing, that is estimation of the manufacturing cost. Okay, so you refer the exhibit 11.4. Okay, that is the input and output model for the manufacturing system, any manufacturing system. So the inputs are raw materials, and the inputs are labor, and the inputs are purchased components. Okay, and the inputs are machines. Okay, so the auxiliary, the supporting devices or the equipments for production or manufacturing is equipments we need tooling we need, and we need some of the information, and we need energy, we need suppliers, we need services for the manufacturing system. So there will be material input, and there will be labor input, and there will be purchase component inputs. So in the manufacturing system, we need to convert, okay, these raw materials, okay, into finished components, and finished components and purchase components have to be sent for assembly, sub-assembly. Okay, and then we need to generate the finished products as output, and there will be some of the wastages which will be occurring during the production system, that is going to be separated. So this model is known as input output model for manufacturing system. For design for manufacturing, we need to know about this, the input output model of manufacturing system to analyze the manufacturing system. Okay, so again, the input includes, as I told you, that there will be materials and there will be purchase components and the employee effort, energy, equipment. Okay, the output includes the goods and the waste. The manufacturing cost is the sum of all the expenditures for the input of the system and for the disposal of the waste produced by the system, and the metric of the cost for the product. Firms generally use a unit manufacturing cost, the which is computed dividing the total manufacturing cost for some period by the number of units produced or manufactured during that period. This is a simple concept, is complicated in practical by several issues. Okay, what are those issues? Okay, the calculation of the final production cost, it looks very simple. Okay, that is nothing but the total amount of the manufacturing cost during some certain period of time and the total number of product produced for that certain period of time. Okay, if we use this, we can calculate, okay, the total cost of the manufacturing for a certain period divided by the total number of the products produced during that period. That gives the cost of the product per unit. Okay, but it looks very simple, but it has not, practically there are certain issues. What are those issues? What are the boundaries of the manufacturing system? Okay, what boundaries we are restricting for the manufacturing cost? And should the field service operations are to be included? What about the product development activities? So here we need to decide the boundaries for calculation of the manufacturing cost. Okay, what activities have to be included is to be, in reality, we need to add each and every activity of the supply chain. Okay, from the ordering of the raw material, procurement, manufacturing, and give it to the market till it reaches the customer's hand. What are the money we spend? That amount is to be taken into consideration for evaluation of the product cost. Understand? So then second boundary is second boundary is how do we charge the product for the use of expensive general purpose equipment. Okay, so we use some of the many general purpose equipments. Okay, how to charge for those general purpose equipment, and each general purpose equipment, they have got their own life. Okay, they have got certain life. As human beings, we have 100 years of life. Okay, and effectively we can work for another 60 up to 60 years. After that, another 40 years, the life is not very miserable and horrible, and we cannot work as we work before 60 years. So in this context, even the machines or the equipments, even though they have a life of 10-15 years of life, they do not work all 15 years satisfactorily as economically as we anticipate. Okay, so as the life passes, the maintenance and repair cost increases. So in this cost, how to charge those additional special equipments to calculate the manufacturing cost? That's also a big challenge. And how are the costs are allocated among more than one product line in the large? Then how to categorize the cost if there are varieties of products are being manufactured in the different lines of the production system? Then how to calculate the cost of the each product variety? This is also a big challenge for the manufacturing engineers. Okay, so then again you referred one more figure, that is 11.5, the elements of manufacturing cost of the product. Okay, here the manufacturing cost we need to calculate. So we need to calculate the cost of the components, cost of the assemblies and sub-assemblies, and the overhead charges. So the cost of the components, how to calculate? So we use some standard components and we use some custom components. Then what do you mean by custom component? Custom components are nothing but the raw materials, and those raw materials gets into converted into processing, the processing cost, and we need to and also we need some jigs, fixtures. Such things are part of the toolings, cutting tools, other things. So they are there, they are part of the toolings. Okay, the work holding devices and other jigs, fixtures, all the things comes under the toolings. Okay, all these costs are going to add to the custom components. Then assembly. So for the assembly we need to calculate what are the labor cost and also the equipments and tooling cost. Okay, and overhead cost, how it's going to be calculated, the supporting activities cost and also the indirect allocation cost. So all these costs have to be included in calculating the manufacturing cost of the product. Okay. Okay, so then components cost we know, and what is the assembly cost we know, and what are the overheads. Okay, in the overhead calculations we need to classify what are the direct cost and what are the supporting costs, what are the indirect costs and direct costs. So we'll little elaborate on these things. Okay, the overhead is a category used to encompass all other costs. We find usual distinguish between the two types of overheads. One is known as supporting costs and another one is known as the indirect allocations. So the supporting costs are those associated with the material handling cost, quality assurance cost, purchase cost, shipping cost, receiving cost, facilities cost, equipments and tooling maintenance cost. So these costs are called as supporting cost. Okay, then there are other supporting systems required to manufacture the product, and those costs are generally depend upon the product design. Nevertheless, since these costs are often shared by more than one product line, so these are lumped together in a category of overhead. So indirect allocations are the costs of the manufacturing that cannot be directly linked to particular product, but which must be paid for to be in the business. For example, salary of the security guard and the cost of the maintenance of the product, and the difficulty to allocate directly to the specific cost, because indirect costs are not specifically linked to the design of product, then are not relevant to design for manufacturing, even though they do not contribute to the cost of the product. Okay, so we need to consider the fixed costs of the manufacturing and the variable cost. Okay, then what are the fixed costs? Fixed costs are those incurred in the predetermined amount regardless of the how many units of the products are manufactured. Okay, for example, purchase of the certain equipments. Okay, the injection molding required for the intake manifold. So is the example of the fixed cost. Okay, example of the fixed cost, whether 1 million units are produced, the fixed cost of the mold incurred and do not change. Okay, whether we manufacture 1, whether we manufacture 100, whether we manufacture 1000, the cost of the equipment remains the same. That is going to be taken as fixed cost. Even the land cost, even the building cost, and even the machinery cost, they have to be taken as a fixed cost of the assets, a fixed cost of the building. The variable costs are those which are directly linked to the quantity of the goods produced or the product produced in the industry. That is the number of the raw materials what we purchase. Okay, that is the cost directly involves. Okay, as the variable cost. So like this, we need to have what are fixed costs, what are variable costs, what are supporting costs, and what are indirect allocation costs. All the cost information we should have, then only we can actually calculate the cost of manufacturing. Okay, and we need to prepare a bill of materials. Bill of materials is about for any product. So what all the components are required, okay, including washer, including nut, okay. So all the details of the components which are going into the assembly of the product manufacturing is called as bill of materials. Okay, the General Motors has given a bill of materials in the exhibit 11.4. Okay, they can use the table to calculate the cost of the manufacturing. Okay, they have used components and the purchase of the material and the processing, that includes the machine and labor cost and the assembly labor cost and total variable cost they have calculated. And then what are the tooling costs are involved, what is the tooling life, and what is the total unit of the fixed cost. Then fixed cost and variable costs are added together individually for each material. Then the total cost is calculated, and after summing up all the total cost of all the components, okay, that gives the total cost of the sub-assembly or the product to be manufactured. So it is one of the important parameter, that is the bill of material preparation, and also estimate the cost of the standard components which has been purchased from the supplier, what is the logistic cost, what is the ordering cost, what is the transportation cost of the standard components has to be calculated adding to that, and also the estimation of the cost of custom component. Custom components are nothing but the raw material which has been gets converted into finished product. What is the total cost involved in that manufacturing, supporting cost, indirect allocation cost, variable cost, fixed cost, everything is to be added to that custom component, and that is to be calculated. Okay, then estimation of the overhead cost, that's also important. Okay, in the first phase we need to calculate all the costs involved in manufacturing. That phase is called as first phase, estimation of the manufacturing cost. Okay, you should know the input and output model of the manufacturing system to understand the first phase of the design for manufacturing. Okay, students, kindly take the one question. What do you mean by design for manufacturing? What is DFX? And in this, what X defines and stands for? Next question. What are the principles or methodologies applied for DFX? Then identify the steps involved in DFM process, design for manufacturing process. Discuss in detail how the estimation of the manufacturing cost is being done in industries. Explain with input-output model of manufacturing. Thank you guys. Okay, again in the next class we'll discuss about the other steps or other phases of the design for manufacturing. So you view this video frequently, many times, and note down the points and answer the given question. See you.